Hello, welcome everyone to lecture number 12 of Fundamentals of Computing. In the last lecture, we discussed about the algorithm, flowchart and the pseudocodes. We have also discussed what are the differences between the algorithm, flowchart and the pseudocodes, and some basic algorithms that we have discussed. For example, the sum of the two numbers or largest among the two numbers and the largest among the three numbers. In this lecture, I'll discuss some more examples of algorithms and flowchart that gives you an idea how to rate an algorithm and draw a flowchart for a given problem. So this topic will cover operators representation in an algorithm, means how the operators are represented in algorithm or the flowchart, and some of the examples of algorithm and flowchart. So first start with the operators, mathematical operators. These are plus, minus, multiplication, division, power, modulo. So how these are represented? Plus, this is same as we use a plus b, subtraction a minus b, multiplication as this, division in this form, and power, that is a into a into a. This will be represented as a to the power 3 by using this symbol, and modulo is represented by using the symbol that finds the remainder. Another operator, that is relational operator. This can be represented as less than, will be represented as a less than b, less than equals to will be represented in this form, greater than that we use, that is a greater than b, greater than equals to for checking whether a is equals to b or not, we will use this symbol, that is double equal sign, and this represents the not equal to. Logical operators that I already told you, which was and, or, and not. So this can be either used in this form, capital A and D. Sorry, it should be capital or. Instead of and, it should be or. There's a correction. And means what? When A is less than B is true and B is less than C, if both of them are true, then the result is true, otherwise false. Or means what? Either of this condition, that is A less than B or B less than C is true, then it is true, otherwise it is false. Means it's false only when both the conditions are false. If any of them is true, then the result is true. Not means what? It's simply a negation. If it is 0, then it becomes 1. If it is 1, then it becomes a 0. Means if it is false, then the not of false will be the true and not of true will be the false. Okay. Apart from that, we also use some selection control statements in algorithms and the flowchart that I have already used in finding the largest among the two numbers and the largest among the three numbers. Means that there I have used what? The if statement. So if condition is there, then you have to execute something, this statement gets stopped. It means what? If x is greater than 10, then you have to print what? Or not the print, you can say, then the value 5 is assigned to a. If you want to check more than one condition, then you can use the if is statements. It is says what? If condition, then execute that. Else you want to check it, or you want to execute some statement, that will be put in between the else and end if. So what the example says, if x is greater than 10, then we do what? A is equals to 5. Otherwise, that is else, b is equals to 9. So these are the logical operators, mathematical relation operators, selection control statements used in algorithm, in any algorithm or any flowchart for solving a particular problem. Apart from that, we also use this go to. You can either write it in the capital or in the small. What it says, it is an unconditional transfer of control statement, and it is used to transfer control of execution to another step, or you can say statement. This simply equals to sign. This is called as an assignment operator, or for that we can use this symbol also. A equals to B means what? The value 2 is assigned to A. Okay, so these are the basic things that are required for writing a algorithm. Let's start with the example. First example is finding area and perimeter of a square. So very first questions comes into the mind, how you can find the area and the perimeter of a square. So we all know that area of a square is nothing but L into L. L means what? You have to, L represents the length of any side. So when we multiply L by L, then we get what? The area of a square. And similarly, for finding the perimeter, we use what? The formula is 4 into L. So this is for the L into L is for area, and 4 into L is for the perimeter. So how we can write the algorithm? Simply, first one is the start. Okay. Then obviously you have to read what? The length of any side. So read L. Then what you have to do? For computing the area, suppose I have used a variable area that stores the area of a square. So this will be equals to what? L into L. Then for finding the perimeter, suppose I have used the variable that is peri, which stores the perimeter of a square. So according to this formula, it is equals to nothing but 4 into L. It means what? Area, this is stored in this variable, and 4 into L, this is stored in the peri, that represents the perimeter of a square. So finally what we have to do? We have to print area and the perimeter. This is the output that we want to have. And after that, stop. So this is the algorithm for finding area and a perimeter of a square. What is how we draw the flow chart of it? So first one is what? It's a start. Okay. Then you have to read what? L. So we use this symbol for reading. It's read L. Then next step is what? Computation. So I can combine these two steps together in the same box, or I can use the different box for area and for peri. So here I am combining both of them together. So here I can write area is equals to L into L, and peri, this is equals to 4 into L. After that, what you have to do? Print these two. So for printing, we use the symbols. Then we write simply here what? Print area, and we put a comma for peri. So this will do what? This will print the area, that is the value which is stored in this variable named area, and the perimeter, which is calculated as 4 into L, its value is stored in peri. And once it is done, then you have to stop. So this is the very simple example for writing an algorithm and flowchart, which computes what? The area and perimeter of a square. Okay. Let's take another example. Here what we are going to do, you have to interchange values of two variables by using temporary variable. It means what? Suppose I have taken a variable A and variable B. If I have stored a value 2 in A and 5 in B, so after interchanging, what becomes? A will store 5 and B will store 2. This is called the interchange. So now here it says what? You have to use the temporary variable. So how we will do that? What is the logic? Logic says, okay, we use some temporary variable, say t, in which I have stored the value which is written in A. Okay. Then we assign what? The value which is stored in B to A. So what will happen here? If I take this as a A box and this take as a B box. So what will happen from this? The value B gets stored into A. It means what? 5 gets stored over here. Then obviously I have to take what? What is the value in A? That should be here. So I cannot write B is equal to A over here, because if I write B is equal to A over here, then it becomes what? The 5. What I want to have? I want to have this 2 over here. So what I have to do? Since T, this T stores what? The value which was in A. It means what? What T stores? It stores 2. So here I will write T, B is equal to T. And the value that gets stored in the B is equals to 2. So this is the logic which does what? Which does the swapping of two variables. Now we have to write an algorithm and draw the flow chart for this. So for algorithm, it's a start. Then next, you have to read these two variables, say A, comma B. Then what you have to do? Next step is you have to use the temporary variable. So before doing that, first print what value is stored in A and B. So print value before swapping. So before swapping means what? What is the value which is stored in A and B? So obviously it will print what? A is equal to 2 and B is equal to 5. Then we use some temporary variables, say temp. So this will equals to what? A. Then B is equals to what? A. And then A is equals to temp. Okay. So in this way you have what? Interchange the values of A and B. It's like this only. T is equal to A. Then this A is equal to B. So I have written what? B is equal to A. That has to be corrected. From here you can see you have what? Debug your algorithm. How you have debug? Because here you have seen what? T is equal to A. So yes, T is equal to 2. Now again I have written what? B is equal to A. So B is equal to A means what? The value which is stored in B, that is the 2. So that comes before this. Instead of that, I have to write what? Here A is equals to B. And then according to this, B equals to temp. So from here you can check it out whether this you have written is correct or not. So what I have taken, A is equal to, before this I have taken A is equal to 2 and B is equal to 5. So what will happen over here? Temp is equals to 2, A is equals to 5 and then B is equal to what? 2. So that's what you want to do. Finally you want to have this. So next, print what? Values after swapping. So values after swapping is what? Now here A prints what? When I write A, it prints 5 and B prints what? 2. That's what we require. Then finally stop. So this is the algorithm for interchange of two variables by using a temporary variables. Here I have also debugged the algorithm at the same time. You have seen that I have written this statement B is equal to T before the A is equal to B. So then I have corrected it. How I have corrected? Because I have checked simultaneously what is the value which is transferred to A and B and TMP. So if you have written any algorithm, you can check it also whether it's correct or not by putting some values into the variables and go step by step. Then you can check it out, it's whether the output that you are getting through that algorithm is correct or it's wrong. So now draw the flow chart. For the flow chart, yes, start, because flowchart is nothing but it's a pictorial representation of algorithm. So first step of the algorithm is a start. So I start. Then the next step says what? Read this A and B. So read A, B. Then it says what? The print the values of A and B before swapping. So I simply write here what? Print A comma B, that it prints the value of A and B before swapping or interchange. Then this 4, 5 and 6 steps are there. I can combine it together and put it in a single box. So it says what? TMP is equals to A equals to B and B is equals to TMP. And then, so TMP is equal to A. From here, what value is going to be stored? 2. Then A is equal to B. What is the value which is going to stored in A? 5. And then B is equal to TMP. It is going to store what? 2. Then print the value after swapping. And then stop. So what is the value which is printed over here? Here it is 2, 5. And after swapping it is 5, 2. That's what is required. Again we will do the same problem, but here we won't use the temporary variables. In the previous case, we have interchanged the values of two variables by using the temporary variables. Now, this is the problem. Problem says what? You have to interchange the values of two variables without using the temporary variable. So first we have to find out what are the steps, what is the logic that is required to solve this. So what it says, you have read what the two variables A and B, assign some values into it. Now you won't use a temporary variable over here, but you have to swap it, interchange this value. So how it can be done? If I write A is equal to A plus B and then B is equal to A minus B and then A is equal to A minus B. Is it going to solve our purpose? So let's check. Suppose take value of A is equal to 5 and B is equal to 6. So what it does? According to this step, A will be equals to what? A plus B, that is 5 plus 6, that becomes 11. Okay. Then this step says what? B is equal to A minus B. Now the value of A is 11. So 11 minus B, this becomes what? Value of B is 6. So here we take what? The 6. 11 minus 6 becomes what? 5. Okay. Then A is equal to A minus B. So A is what? Here it's 11. So we take 11. What is the new value of B? That is what? Your 5. So 11 minus 5, that becomes 6. Obviously this you required. It means what? Now what is the value of A? A is equal to 6 and B is equal to 5, which represents the interchange of value of A and B without using the temporary variable. So here I have used this step and checked it also whether what I have written is giving the right result or not. So let's write its algorithm. First step says start. Then second is read the value of A and B. Then what you have to do? Yes, this steps is to be followed. This one to get this result. So we do what? Actually we want to see also what is the value of A and B before swapping and what is the value of A and B after the swapping. So for that we have to write here one more step, that is print the value of A and B. That is what? Before swapping. Then do what? A is equal to A plus B. Then write B is equal to A minus B. And then write A is equal to A minus B. And then we again want to check what is the value. So we print what? A and B. This is the value which we get after the swapping. So this is the algorithm for interchange of values of two variables without using temporary variable. So what's the flow chart of it? Yes. First step is what? Start. Then next step is read. So we read what? Or you can say input A and B. Then it says what? Print. So it print the value of A and B, that is before swapping. And then these steps, so I will combine this 4, 5, 6 together. So it will be in this box, A is equals to A plus B, then B is equals to A minus B, and then A equals to A minus B. And after that, print A and B. So it's what? Print A comma B and then stop. So this is the algorithm and flow chart for the interchange, or you can say swapping of values of two variables without using the temporary variable. Okay, let's do another example. Here you have to write an algorithm and draw flow chart for finding even numbers between 1 to 100. So it means what? Your range is from 1 to 100. What are the even numbers between these? Obviously it is 2, 4, 6, 8 and so on. And here you have to stop when 100 comes. And you have to start from where? From the 1. So this is the range of numbers that you have to print. So what should be the algorithm for this? Obviously it's what? First I'll write the algorithm, then I'll explain it. It is a start. Here I'm using a variable I and I assigned a value 1 to it. Then I'll check if I is greater than 100 or not. If it is greater than 100, then go to, now here I am using the go to statement. Go to step 7 because I have used end, so its end if indicates what? End of if statement. Then again I'll put a condition if I modulo 2 is equals to 0, then print I. So again end if means this indicates the end of this statement. Then I is equal to I plus 1, and then I write go to step 3 and then stop. So you can check what you have written. Let's say I is equal to 1. So for I is equal to 1, I is greater than 100? No. Not, then you have to go where? To this step. So here you have to find out I modulo 2. So I modulo 2, here I is equal to 1. 1 modulo 2, it is equals to 0? No. So where you have to go? You have to increment the value of I by 1. So I is equal to I plus 1, that becomes 2. Then again it says go to step 3. So here I have to go here again. Again I have to check whether 2 is greater than 100. No. Then I move to where? The step number 4. Here I'll check I modulo 2 is equals to 0. Yes. 2 modulo 2 is 0. So what I have to print? I'll print 2. Then after that I'll go to step number 5. So I is equals to what? 3. Then it says go to step 3. Then again I have to check I is greater than 100. No. So I will move to step number 4, which says 3 modulo 2 is equals to 0. No. Then I is incremented by 1. I is equal to 4. Then again I will go to step number 3. So this process repeats till I is equals to 100 to print the what? Your even numbers. I hope it's clear to you. Let's draw the flow chart of it. So first one is start. Let I have a start. Then I assign the value 1 to variable I. Then check if I is greater than 100. It may be greater than or it may be not. If it is not, then moves to no, to the next. Next is what? As step number 4. Again you have to check what is the condition. If I modulo 2 is equals to 0 or not. It may be yes or it may be no. If it is no, then you have to do what? I is equal to I plus 1. This one. If it is yes, then you have to do what? You have to the print I here. Then again go to what? Step number 5. So I is equal to I plus 1. When you are at I is equal to I plus 1, then where you have to go? To the step number 3. Step number 3 means what? This one. You have to check whether I is greater than 100 or not. If here this is the no condition of this one. If it is yes, then it means what? What do you have to do? Go to step number 7. What the step number 7 says? Stop. So stop. So this is the flow chart for finding even numbers between 1 to 100. Okay. We have other algorithms also, but due to time constraint, I'll discuss in the next lecture. Thank you.